As a web request plunges through an enterprise network, it sheds UI and API gateways, stripping away abstractions until hitting the raw server engine underneath. In countless environments, that engine is Apache Tomcat. It operates silently in the background of internal HR portals, legacy admin tools, and modern API platforms. Over the past year, the Tomcat project has published a steady cadence of security patches, addressing flaws in clustering encryption, URL rewriting and request handling, and default servlet authorization behavior. A newly disclosed CVE does not mean every deployed server is remotely exploitable. The practical risk depends heavily on which specific features and network paths are active in production. But Tomcat's immense ubiquity creates a scale problem. A single configuration flaw on one widely deployed application server rapidly becomes a widely repeated enterprise threat. DevOps teams frequently assume an application server is safe as long as it sits behind an upstream reverse proxy or web application firewall. That assumption creates an operational blind spot. The critical danger emerges when the WAF's assumptions conflict with Tomcat's actual runtime behavior. Recent vulnerabilities expose 4 distinct failure modes where this misalignment occurs: proxy mismatches, exposed internal cluster traffic, authorization bypasses, and logging data leaks. Attackers do not need to break the perimeter directly. They target these precise edge cases to bypass perfectly configured upstream defenses. Effective threat modeling must expand beyond reviewing the codebase. It requires analyzing how interconnected infrastructure components interpret the exact same requests differently. This diagram shows a split-screen logic flow of a proxy chain. Network security relies on every layer in this chain interpreting a request the exact same way. CVE 2026-59083 exposes a flaw where the Tomcat rewrite valve component mishandles specific encoded characters in rewritten URIs. The upstream WAF inspects the encoded character, interprets it as safe, and approves the traffic flow. Tomcat then decodes that identical request and routes it unexpectedly toward a restricted path, like an admin interface. The malicious payload looks benign to the upstream defense, but executes entirely differently downstream. Attackers leverage this exact discrepancy to bypass intended access rules around rewrite policies, slipping past the WAF unnoticed. Upstream access controls offer zero protection if administrators fail to test how their proxies handle unusual inputs and path normalization edge cases. There is a pervasive fallacy in infrastructure design that internal cluster traffic is inherently secure simply because it operates inside a private network. In reality, flat network architectures and cloud security group misconfigurations frequently leave internal clustering ports exposed. This diagram maps a cluster using Encrypt Interceptor. When an external probe penetrates a compromised firewall rule to reach these ports, vulnerabilities like the CBC mode padding oracle risk in CVE 2026-29146 become critical. An attacker reaching these ports can exploit the padding oracle flaw to break the encryption layer and compromise communication between cluster nodes. The Apache security model explicitly states that while encryption is active, it does not protect availability against denial of service attacks or targeted manipulation. Cluster communications must be strictly isolated to known, trusted nodes at the network level. Application layer encryption never replaces strict infrastructure-level network segmentation. Administrators routinely attempt to protect resources by deploying security constraints that block standard HTTP methods, like GET or POST requests. This diagram illustrates a standard HTTP GET block. CVE 2026-55956 reveals a failure where security constraints on the default servlet ignore configured HTTP method omissions. An attacker simply sends an unusual or unmapped HTTP method that the primary constraint is not programmed to recognize. Because the specific method isn't explicitly defined in the block list, the unmapped request circumvents the intended block, flowing directly to the default servlet. The exploitability of this behavior depends heavily on how hyperlocal mappings and constraints are configured in the environment. Application server security policies are only valid in their runtime execution. Static assumptions written on paper are a dangerous operational liability. Centralized logging architectures are designed to aggregate and retain data from an entire server fleet for very long periods. CVE 2026-34487 highlights a vulnerability where a clustering cloud membership component inadvertently logs a Kubernetes bearer token. This model tracks the lifecycle of that log message. As the text log exits the Tomcat server boundary, it enters a wide, centralized CM pipeline. The centralized logging system instantly replicates this sensitive token across multiple internal storage buckets and analysis nodes. A plaintext secret is now openly accessible to internal analysts, contractors, and third-party support tooling. A minor data leak at the application tier instantly expands the blast radius into entirely separate, highly privileged trust zones. This triage matrix shows the critical operational difference between a standard Apache security advisory and CISA's known exploited vulnerabilities catalog. Standard advisories act as a trigger for careful assessment and scheduled patching based on your specific configuration. Vulnerabilities listed in the CISA KEV catalog elevate the risk to a confirmed active threat, requiring immediate remediation. Step 1 of triage is a strict audit. Identify and eliminate end-of-life deployments. Step 2 requires mapping enabled features. Aggressively disable unnecessary components to instantly reduce the attack surface. Prioritize patches based on environmental exposure and CISA intelligence to manage risk. Securing modern Java applications demands expanding focus far beyond application code and dependency files. The application server, proxy alignment, container images, and cloud identity hygiene are critical components of the software supply chain. A fully patched server left unmonitored or one retaining legacy configurations remains a high-priority risk. Take inventory of the exact versions running, disable risky features, and rigorously test reverse proxy edge cases against Tomcat's runtime behavior. A security patch stuck in change management provides zero defense. True security requires building an automated pipeline where hardening and exposure checks are continuous.